Now, I don't know if you can see figure 26 on the camera or not, but there it is. I'll even bring it closer to the camera, and maybe at some distance you can see it pretty well. But what we have is just a bunch of graphs that all represent power functions. I don't specify what power function is what. I don't specify what the y factors are. You could estimate them. I don't specify what the powers are. If you can find the y factors, you can find the powers. The graphs kind of vary from one like this to one like this, and then there's just a bunch of them in between of varying degrees of upward or downward concavity. So, when I use the term y factor, and this kind of got smudged out in handling the board, but when I use the term y factor, I mean the y factor of the original graph. So here's the original graph, here's the slope graph, okay? So the y factor applies to this one, not to this one. Although this one might well be a power function graph and might have some kind of a reasonably consistent y factor. So my questions related to this, and this was a group project that was assigned. One question: are some graphs concave down? Now, when we talk about this, I'm talking about some of the original, not the original graphs. Actually, I say, are some slope graphs concave down? We mean slope graphs of the original graphs, okay? So some of the slope graphs here will be concave down, some might be concave up, some might be increasing, some might be decreasing. Maybe none of them, though, are concave down. Maybe none of them are concave up. You have to construct a series of slope graphs to see how the slope graphs change as you go from, let's say, the lowest function to the highest in increments. There are actually 14 graphs, if I count them correctly, on the figure. Now, not everybody will do all 14, so I'm asking the group to assign everybody a task or a set of tasks and come back and report tomorrow so the group can process the information. So there's this. Are some slope graphs concave down? Are some slope graphs concave up? For what y factors will the slope graph clearly be concave up? And for what factors will it be clearly concave down? There might be some where you can't tell. Like if you get points that look like this when you construct your slope graph, you really don't know. Maybe it's concave up, maybe it's concave down, and maybe it's neither. Okay, now again, when we say y factors, we mean the y factor of the original graph. For what y factors of the original graph will the slope graph clearly be concave up? For which concave down? Now, I shouldn't have to write this. I don't have to write this, but I'm going to write it. For what y factors of the original graph. Okay. Then, as the y factor increases, what happens to concavity? Okay. Now, in what direction is the y factor increasing on these graphs? Does it increase as you go from this graph to this one? Or does it increase as you go from this graph to this one? Or does it maybe start in the middle and increase till you get down here, then jump back to the middle and increase till you get up here? There are all kinds of ways. So you can estimate what the y factors are so that you can really answer that question and understand a little more about the progression of the y factors and the progression of the slope graph behaviors. Okay, should there be a y factor such that the slope graph is neither concave up nor down? Now, I don't use nor since I use neither, so let me throw that in there. Okay, should there be? Is there evidence that there would be? Is there evidence that compels you to think that there probably is, or is there evidence that compels you to think that there probably isn't? If you investigate this, you can answer that question. How is the y factor of the slope graph related to the y factor of the original graph? If, of course, the slope graph is a power function, that of a power function, if the slope graph has a consistent y factor. So it might be an improperly posed question. If the slope graphs don't have something that would reasonably be interpreted as a consistent y factor, then the question has no meaning. The question assumes that there is a y factor for the slope graph. Doesn't mean there is one. You have to decide. So that's a task given to the entire group. We'll see what the group comes back with.